Okay, today we are finishing up the true false section. I only have 5 questions for us today. I have taken some of these off because some of them are either applying to things that I was able to skip for you or applying to things that, in all honesty, don't really apply to the entire rest of the book. So I skipped some of those. It's okay. I've only typed up the stuff that we either covered or we covered in depth or that you should know going into all of this. So don't worry about that. Okay, so 21. There's only one circle that can be drawn tangent to the sides or sides extended of a triangle. Okay, so I'm going to draw a triangle. And I've got to draw something tangent to the side or sides extended of a triangle. Okay, so I'm going to draw a circle here. And I'm going to say that this is tangent. Okay, I'm also going to draw a circle here. I'm going to say that that's tangent. I'm going to draw a circle here. Oh, that's a tangent. Circle here. That's a tangent. Do you see where I'm going with this? Because it said to the sides plural or sides extended, this is actually false. I can have almost an infinite amount of circles drawn tangent to any of the sides of this triangle. Okay? If the altitude of an equilateral triangle is 6, the perimeter and the area of the triangle have the same numerical measure. So let's just simply draw what we're going to say is an equilateral triangle. So I'm going to do this. I'm drawing my altitude, and my altitude is 6. So the perimeter and the area of the triangle have the same numerical measure. I know that this is my long side in a 30, 60, 90 degree triangle. So I know that this is actually whatever this is times the square root of 3. So I'm actually going to divide that by the square root of 3. I have to use my phone again, so it's going to take a little while. I left my other calculator across the room, but that's okay. So I'm going to go 6 divided by square root 3. I'm going to use decimals here. So I know that this is 3.46. So I'm going to double that. So my entire side is 6.93. Okay, so my entire length is 6.93. So if I multiply that by 3, I get my perimeter. And then if I take half of this times that, so I've got 1/2 base times height, because this is the same size as this. So if I do 6.93 times 0.5 times 6, you will find out that I actually get that my area also equals 20.79, but again, I did use a shorter version of that. I had rounded that up. I'm gonna say that's pretty close. So I'm gonna tell you, yeah, that's actually true. Now, a shortcut for this is seeing the altitude is 6 and knowing that the area of a triangle is 1/2 base times height. I could actually see that it's gonna be 3 times the base, so 3 times the side, which is going to give me, yes, the same perimeter and the same area, because that's how I find the perimeter of an equilateral triangle. Okay. The converse of any one of the congruent triangles theorem is true. So let's talk about the congruent triangle theorem. So we have SSS, SAS, ASA, I believe those are the main 3. Let me see if I'm missing any. Oh, I can do AS. Yep, but I can't do, because remember, we don't cuss in geometry, so I can't do any of the ones that would spell out a bad word forwards or backwards. So this would give us these 4 here. I actually found that out from a Christian geometry teacher. They told me that is the we don't cuss in geometry, so the congruence theorems can't spell anything that looks like a bad word. So here we have side, 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 angle, angle, or angle, angle, side. So in a congruent triangle, the triangle theorems are saying, so if all 3 sides are equal in both triangles, they are equal. If sides and their included angle are equal. If angles and their included sides. So this is actually true, because if I go backwards and I say, oh, they're congruent, then any of these statements is also true. So if they are congruent, all their sides are equal. If they are congruent, 2 corresponding sides and their included angle are also equal. So you can see that that is true if you just simply write out the congruence theorems and then go backwards from them. Okay, if one angle of a triangle is double the other, the side opposite the first angle is double the side opposite the second angle. Easiest way I can think of is to, well, let's look at our special right triangles here. Okay, so I've got 45, 45, 90. This is x, this is x square root 2. So this one right here, I can stop after this one. I'm gonna do the other one just to show you, but 45 is half of 90, which means that my hypotenuse should be double the length of my leg. However, it's not. It's times the square root of 2. Automatically, this is false. We can also see that with the 30, 60, 90. Okay, so if this is 30, this is 60. That would make it seem like this is x, this should be 2x. However, this is x times the square root of 3. So you can actually see here, 2x is my hypotenuse. So if it is triple, it ends up being double the side. Or at least that's my conclusion from this. However, the true-false statement is false because it's asking about if the angle is double, then the side is also double. That is not true. Okay, and lastly, the parallelogram of greatest area inscribed in a given circle is a square. So parallelogram, we are talking simply about the fact that it is a four-sided figure. So four-sided. Because we have rectangles, we have squares, we have rhombuses, okay? So it is saying that it has to be a square. However, I can have a square that's 4 and 4 and a rectangle that's 8 and 2 that could both be inscribed in a given circle. No, I can't do that in the same given circle. But, well, actually, I don't know, because if the diameter is 8, anyways, it all depends on the radius. But you can see that I have the chances of having two different figures that have the same area. So I'm actually going to say that's false, because I think that there is a chance that we may be able to get that to work with rectangle and square, giving us the same, in some scenario out there, giving us the same area. So it's one of those things, there is a measure of a doubt. If there's a measure of a doubt, the answer is false. For these purposes and for this book, they're just trying to teach you to think outside the box. So think outside of just what it's given you. Bring in different information, like all this stuff that we know from previous problems. Okay? I will see you guys on Monday, because that's it for this week. Have a good weekend.